Okay, so welcome back once again, guys. Now, in this lecture, I'll be talking about how to create a neural network based on the example that we have, a data set that we have. So here, if I'll talk about my data set, so inside my data set, I have 4 column X train. If I'm going to show you, so inside my X train, I have a 4 column, 1, 2, 3, 4. This is the column that we have, right? So we have to pass this particular data inside a neural network. So how I'm going to create a neural network, or what kind of a neural network I will end up creating? Let's try to talk about that. So here, what I can do is that I can try to create a input layer. So where I can try to place 4 neurons, right? And then eventually I can try to create a hidden layer where I can try to give maybe a n number of neurons. Then again, I can try to create maybe like a hidden layer. So where I can try to give again n number of neurons, and then I can try to provide the output layer. So output layer will be having, let's suppose, 3 neurons, because we are trying to do a classification and we have a 3 different kind of a classes. So maybe this kind of a neural network I can try to create. Now inside a hidden layer, right? Inside a hidden layer, so I can try to give a activation function. That's completely fine. So maybe I can try to give a ReLU activation function, rectified linear unit. I can try to go ahead with the Swiss function. I can try to go ahead with the leaky ReLU, but ReLU is like a moderated one. So I think I can try to use that one. Again, here I will be having a hidden layer. So I can try to use a ReLU. And then here, so we have to do a multi-class classification. So maybe I can try to go ahead with the softmax, right? Softmax as an output function. So in this way, I will be able to create a entire neural network structure, entire neural network diagram. Not just that. So I'm going to even show you like after creating this neural network. So I'm going to show you even how to visualize this entire neural network. Even I'm going to show you that it is going to define a random weights, right? It is going to define a random weights, maybe weight 1, weight 2, weight 3, and so on weight n. So what will be the value of the weight? Plus it is going to attach a biases, right? So what will be a value of biases? Each and everything I'm going to show you. Each and everything from the scratch, one by one, step by step, video by video, I'm going to show it to you. So let's start doing it. It's not very difficult, but yeah, so we are going to do a lot of postmortem with respect to this entire neural network, so that once and for all, this fundamental of the neural network will be very much clear. You will be able to visualize it, even if it is going to be a complex neural network for all of us. So here, first of all, to create a neural network, let's start writing a code. And I'm going to use a TensorFlow Keras library, because Keras is a high level APIs, and with the help of that, you will be able to create this entire neural network in a easiest possible way. So here, TensorFlow dot Keras, Keras you can try to call, and then dot, first of all, I have to create a input layer, right? Input layer, for example, this one. So input layer I have to create. So where inside the input layer, so I have a 4 neurons. So here I can try to create a input layers, and then I can try to define a shape. So what is the shape of this input layer? So shape of this input layer is 4. This is something which I have given. Now let me like store it inside a variable called as inputs inputs. Okay, so this is my input layer. I'll show you visually as well, so don't worry about that. So input, and then I have to create a next layer, which is going to be the hidden layer. So I can try to call TensorFlow.keras.layers dot. I can try to call basically something called as dense. So which is nothing but a hidden layer. And inside this hidden layer, I would like to place 10 neurons. I can try to even change it. That's completely fine. Yeah, I can try to even change it. And there is no harm, right? There is no harm. And even if you will go to Google, let me show you one more example. So let's suppose if I'm going to Google, and if I'm going to call TensorBoard. So here, TensorBoard play, let's call that. Yeah. So here, as you can see, we can try to create input. We can try to create n number of neurons inside a first hidden layer, and then we can try to add a couple of more hidden layers, right? We can try to add a neuron, and then we can try to create the output layer. So exact same thing I'm going to create. Exact same thing I will be creating. So let's suppose here I have to create maybe 10 neurons. Here I have to keep maybe 8 neurons. I can do each and everything. And plus you must be able to see a value of weights. You must be able to see the value of biases. I'm going to show each and everything in a depth and in a detail. So here layer name dense, and 10 neuron I'm going to create. So inside this one, inside the very first dense layer or hidden layer, so I'm going to keep 10 neurons. Now inside this particular one, I have to keep activation function as well. So activation is equals to let's suppose I'm going to keep ReLU, yeah, ReLU function, rectified linear unit. And this is going to take a input from the previous one. So whatever output this one layer is going to give, it will be attached as a input over here. Okay, so inputs, that's cool. So this is going to be my, let's suppose I'm going to name it as a X. Yeah, I'm going to name it as a X. Now, if I have to create a next hidden layer, so maybe this next hidden layer, or as per my this diagram, so this is the layer, let's suppose I have to create. Yeah, this is the layer I have to create. So how I will be able to create it? So again, TensorFlow dot Keras, I can try to call dot layers, I can try to call dot dense, I can try to call. I can try to give a number of neurons. So maybe I can try to keep 8 over here. I can change this value. I can change this value. Activation is equals to, again, I'm going to give a ReLU, right? And input inside this one will be the output of the previous layer. So the previous X I'm trying to provide here. Simple, layer by layer, I'm trying to connect each and everything. So here, let's suppose I'm going to save it as a X over here. And then I can try to create a next layer, which is going to be the final layer or output layer, where I will be having 3 neurons, and the function is going to be softmax, so that it will be able to give me probability for each and every classes. So TensorFlow dot Keras and dot layers dot dense, I can try to call, and here, so I have 3 neurons because I have 3 classes, Setosa, Virginica and Versicolor, and activation is equals to, this time I'm going to keep as a softmax, so that it will be able to give me a output based on the probability. So soft max, okay, and the previous output will go inside this as a input, and I'm going to name this layer as a output output. Okay, so this is something which I have created. Now I have to build the final model. So to build a model, I can create a variable called as model. I can try to call TensorFlow dot Keras dot model, TensorFlow dot Keras dot model, and here, so model input is going to be inputs that I have created in the very first line, this one, and model output is going to be output. So it should be inputs, that's the variable name, and outputs which I have created. Yeah. So this is going to be my model, by the way. This is going to create my model, and this model is a very, very simple model that I have created. So where in a very first input layer, I have 4 neurons, right? So 4 neurons, as I have a 4 column. Then inside a next layer, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neuron. Then in a next layer, I have 1, 2, 3, 4, 5, 6, 7, 8 neuron. And in the output layer, 1, 2, and 3 neuron I have. So this is basically my input. This is my input. This is basically my output. This is my hidden layer 1, and this is my hidden layer 2. And all of this neuron will be connected to each other, right? All of this neuron will be connected to each other. Again, all of this neuron will be connected to each other. And here there will be a weight. So I'm going to show you each and everything, that what kind of a weight it is going to initialize with layer wise, right? Layer by layer. So what kind of a weight it is going to be initialized with. And here, so we have an activation function as a ReLU. Here we have an activation throughout the layer. And here we have an activation function as a ReLU. And here basically we have a soft max, right? We have a soft max over here. So this is a very plain, simple and a basic neural network that we have ended up creating. Okay, that's cool. Now layer by layer, if I have to show you, so model.summary I can try to call, and it is going to show you the layer by layer information, that okay, so there is an input layer, and there was a 4 neuron parameter, trainable parameter is equal to 0. There is a next layer, basically a dense layer, so where neurons was 10 and parameter is 50 that you have to train. Now there is another dense layer, parameter neurons is 8, parameter is 88. Then there is a final layer, and here, so neurons is 3, and then parameter is 27. So in total, the size of the model is 660 byte. This is the size, and a trainable parameter that we have is equal to 165. Now going forward, in my immediately next lecture, I'm going to show you that how we can try to visualize it. Yeah, how we can try to visualize it as a image, the same model that we have. So how I will be able to visualize this particular one. So with that, thank you so much everyone. Take care and see you again in my next lecture where I'm going to show you the visualization.